Hello everyone. In this video I will briefly describe visualization of data or graphical display of data in the statistics. So visualization of data is representation of information in the forms of charts, diagrams, pictures, etc. And they are created to visually represent the information uh, that are derived from data. Some of the important characteristics of visualization are that a visualization should be able to display the data discovery without the presence of the original data or the tabulation. So the visualization itself should be self-explanatory without even the original data being present. So if we were to use this example of a bar chart as an illustration of these characteristics, we would say that this bar chart or bar graph actually has the characteristic that without having a worksheet or a table of information, we can actually look at this chart and say what it actually tries to convey to us, or what it tries to represent, or what kind of information it represents. And as you can see, it's a school activity bar chart that has each of these school activities listed here and the number of children that have participated in those activities. The second characteristic is that they must properly have access and their labels. So as you can see, this is the y-axis where the count of the values or data or represented, and this is the x-axis where the each of the bars or each of the categories are represented. And the third characteristic is a legend, source, and date should be included if necessary. So as you can see, there is a title, there is a source, and there is a date included in the chart as well. And lastly, it should be appealing and simple. So when you're creating your visualization, try to keep it as simple as you can, because if we create something highly confusing, it can make it difficult for your readers to understand. Because remember, not everyone is a data scientist or data analyst with the ability to be able to understand the chart as effectively as an expert of data would. And so there are many types of visualizations that I will show you how to create them in SPSS and R. These are the list of the visualizations. The first one is the pie chart, the bar chart, histograms, a line chart, scatter plot, box plots, stack bar chart, group bar chart, area chart, bubble chart, etc. There are at least 30 to 40 of them that I know, but I did not want to list all of them here. But these are among the main charts that are used regularly by the data professionals. I would like to start with the pie chart. Pie chart are used for categorical data. They represent each categories in relation to the whole. So let me go to SPSS and illustrate pie charts through an example. I have a data set of 4 different variables here. I have the variable of name, age, degree, and years in the school. So as you can see, degree is a categorical variable here, and I would like to create a pie chart using this specific variable. So there are 2 ways we can do this. The first way is to simply go to Legacy Dialog and click on Pie, and then click on Define with the summaries for groups of cases selected. And here, since The pie chart again is the count of each of the categories in relation to the whole to the whole sum of the categories. So SPSS will count all the degree categories in their all the counts of all the degree categories and divide them by the whole number of categories. So I would select degree here and put them on the slicer. Since it's important to have titles and footnotes and subtitles, you can fill these out. I wouldn't do it for right now to save some time for the sake of keeping this video short. And the number of cases percentage, you can either select the number of cases, meaning the number of records. For example, in this case, there are 10 records. Or you can do percentage of cases, which is the percentage of each of the categories in relation to their whole number, or do sum of variables. I would do a percentage of cases for right now, and then simply click on OK. So as you can see, SPSS outputted a pie chart for us. You can play with the design and format of the chart by double clicking on the actual chart. And the most important thing is to actually bring the labels, the data labels onto for each of the slices. So by clicking on this the data label mode button and then clicking on each of the slices, you should get the labels. In which case it's the percentages we selected for the chart. As you can see now, our pie chart is created and ready to be used. Each of these slices are associated with a color that are color coded here. Another way to do it is through Chart Builder. So go to Graphs and click on Chart Builder, and on the Chart Builder you'll have to select the type of chart that you want to create. In which case we would like to do a pie chart, so simply drag it onto this screen and then drag the degree category onto slice by, and this should give you the chart. You can also add the titles and the footnotes here by clicking on each of these check boxes. You should get a box here where you can type in the title names. You can also change it from it's right now count. You can also change it to percentage or other values or some of them. So I would keep it at percentage, and then click on apply, and then click on apply again. And as you can see, we created another pie chart. In addition to the one we just created there, we created another pie chart, and we can replicate the same formatting by clicking on the label mode and then clicking on each of these slices. The third way is to actually, since we are counting each of these categories, what if we have a category and a numerical variable, and we would like to count how many times those categories are measured on a numerical variable. In other words, we can factor in a variable to the categorical variable. In this case, let's say we would like to, for example, we would like to see how many years it took for each of these degrees to be obtained. Simply go to pie chart again. Define summaries of groups of cases should be selected. Click on define, and here reset it. Click on sum of variables. So this will allow you to actually use the slicer to the variable to become a variable to the slicer of degrees. In other words, it will count each of the degrees by the variable of this numerical value. It could be age, or it could be maybe years in the school. And remember that these are numerical values, nominal value, categorical values, and if you have the ruler symbol, it's a scale or quantitative value. So once you put the control variable on the variable box and the degree on the slice definition box, you can also add again the titles and the footnotes and the subtitles as a chart should have, and then simply click on OK. So now we have a third chart. Replicate the same format in here. So the third chart explains to us how many years it takes for each of these degrees to be obtained. So in this case, the bachelor's degree takes 16 years. A high school degree takes 6 years. A master's degree takes 9 years, and a PG takes 14 years. So pretty much it counts the total number of these values, these quantitative or these scale values, against each of these categorical values here. I hope this video was helpful. Thank you for your time.